Alright guys, so today we're going to be looking at this worksheet, that one on exponential transformations. So let's start talking about the transformations that we have. So they're here. Alright, so assuming f of x equals 2 raised to the power of x. Again, this number 2, it doesn't necessarily have to be 2. It can be any value. Let's go to the graph over here. You have here the graph of, again, 2x, and that's how it looks. But let's change that 2 to, let's change it to a different value. Let's make it 3. The graph looks exactly the same. Again, it passes. You can see that it passes through the point 1. Let's change it from 3 to, let's make it 7. Again, passes through 1. Let's make it 9. Again, passes through 1. So the graph doesn't necessarily have to be, this value doesn't have to be 2. It can be any value, alright? So that's that. I want to talk about the first transformation, that is whenever you have that exponential function, the 2 raised to an x power, and if you do something like adding anything to it or subtracting anything to it, it'll make the graph shift vertically. So let's check it out. Let's add 1. So if we add 1 plus 1, the graph should go up 1 unit. And check it out. The graph used to pass through this point. Because it went up 1 unit. Now the graph passes through that point. So that's what it means that the graph shifted up. Pretty much the point of intersection will shift up as well. Let's say that instead of adding 1, let's say that I subtract 2 minus 2. Well, let's see if that's actually accurate. So the graph, again, the original used to pass through this point. It went down 2 units. 1, 2 units. There you go. So now the graph passes through that point. So that's what it means to have a vertical shift. Then we have the exponent, the x variable. If we add or subtract any value, adding or subtracting any value. This is the one that's a little bit counterintuitive. The negative, a lot of people think that because it's negative, it shifts to the left, and the positive will make it shift to the right. Here whenever you get something like this, it's actually backwards. The negative makes it go to the right, and the positive makes it go to the left. So on this mode, you can have to edit this exponent to be in parentheses. It's still the same with or without parentheses. X minus 2. So that means that the graph shifted 2 units to the right. It's negative, so it shifted 2 units to the right. So again, the point used to be here. It shifted 2 to the right. 1, 2. And there you go. Right, now let's make a shift to the left. So that means to the left, it has to be positive. Let's go 2 to the left. So 2 to the left. So it started over here, and it went 1, 2 to the left. So there's my point. Pretty much the same graph, was just shifted 2 units to the left. Alright, and again, that, just to say it again, that number doesn't have to be a 2. We can make it a 5. A 5, and we have it here. It went 1, 2 to the left. That number can be any number. It doesn't have to be 5, doesn't have to be 2, it can be anything. You can even make it a decimal, 9.8. Still, it goes through that point. And check it out, because of that plus 2, it moved 2 to the left. Starting here, 1, 2. Nice. And we have one more. Shift on the y-intercept. So pretty much whatever this number is, this will be a shift on the y-intercept. So let's say we have 9. Well, actually let's keep using the 2. Alright, so let's say that times, let's let me open parentheses 4 times because decimal interprets this way. So times, let's make it 3. That means, oh, and let me change that to the original. So we're talking about the original. 3. So we have nothing here, so there's no vertical or horizontal shift. But just this by itself, the 3 makes that y-intercept be 3. So let's see. There it is. The y-intercept is 3. So you should be looking at this first. Check if there's anything being multiplied to something like this, and if it is, you know where your y-intercept is. Alright, but be careful because the y-intercept may be shifted, and that'll pretty much create an extra shift. So 3, whatever that is, whatever this number is, that's where your y-intercept is going to be. Now let's make it go on 2. That means my y-intercept should be at 2. There it is, at 2. Let's make it 7. That means my y-intercept should be at 7. There it is. That's that one. Lastly, the easiest one, I think, it's the negative. Whenever you have negative, pretty much your graph is upside down. So let's go to the original. There's your original. Upside down means it'll be reflected over the x-axis. So again, when you want the negative, check. I'm going to place the negative and notice how it flips. Negative, positive, negative, positive, negative. Just a flip. Negative. There you go. It's flipped. That's what the negative does. That's pretty much everything it does. I recommend applying the negative be the first thing that you do, and then start doing the shifts after that if you have more than one shift. Alright, so these are all of the different shifts individually. Let's now describe the transformations that map the function y to x onto each of the following functions. So let's do this one. Again, this is the original function. Okay, this by itself is the original function. We see it there. What did we do to the original function? We subtracted 2. That means down 2 units. Here, 2 to the x by itself is the original. We added 3. This is the one that's counterintuitive. The negative goes to the right. The positive goes to the left. So this is left 3 units. This one, nothing happened. This is the original function. There's no, well, actually you multiplied this by 2. Yeah, I think this was the one that I told you to skip. Don't do that one. D, here we have several different things. First, go from left to right. We have this one. Then we have that one. And then lastly, we have that one. So the 3 made the y, made the graph pretty much shift 3 units up. You can say y-intercept at 3, followed by a shift, or you don't have to say shift, you can say by a right 1 unit, and followed by an up 1 unit. So let's go. Let's see what this means. So the y-intercept at 3, that'll be for this. The right 1 unit, that'll be for this negative 1. And the up 1 unit, that'll be for this positive 1 there. Alright, so each one of these values pretty much affected the original to the x. Now create a sketch of the graph, each of the equations in question 1. So the sketch doesn't have to be exact, okay? So again, you know that the original graph should pass through 1, and it should pass something like that. It doesn't just make a curve that passes through it. It doesn't have to be exact. You know this graph. Now the new graph, it's going to go 2 units down. So this point, 1, 2 units. Make the same graph, just passing through 1. And there you go. There you go. That's all you have to. Doesn't have to be exact. Then for B, we said 3 units to the left. Left 3 units. I'm gonna let you do that one. Here on B, I'm actually going to do D. Alright? So D. First, the y-intercept was changed to +3. Boom, there's my y-intercept. Then this y-intercept moved to the right 1 unit. Boom, 1 unit. And then it went up 1 more unit. Boom, 1 more unit. So there you go, y-intercept 3, right 1 unit, up 1 unit. There's my point. Again, that's the original graph. So this same graph, it's going to be there. Let me do it. And then I'll show it to you guys. There you go. That graph, it's just pretty much there. Okay? There you go. And these are the transformations. And then on the back here, on number 3, like they're now telling you, whoa, now this 5 to the x is the new original function. If we translate 3 units down, it'll be y equals 5 to the x. 3 units down, that's a -3. 3 units down. On the right, 2 units. It's to the right, so it means the exponent it's gonna be -2 to the right. And this one, translate left 1/2. Treat the 1/2 as if it was a regular number. And then shift up and then left. So you know how to shift it up and down, like this, up and down, and then left. So you know how to shift it left. It has to be positive 2.5. Do that one. Now describe the transformations, the map. So it's these on the bottom here are the same as the ones that we did up here. It's just, again, you have several. 1/2 is the y-intercept, and that's it. Here, actually, don't do B. Don't do it. Here, don't do D. And do D. So pretty much do A and C of number 4. And that's it, guys, for this worksheet.